So this is a short video just to describe what solutions and the best way to approach solutions to this quiz that we had in class of these 5 questions. So I'll just quickly move through each question with a description and having a look at the solutions as well. Question 1, what is the focal point, vertex and directrix of this function? Look, the first thing you've really got to do whenever you get this sort of question is just draw a sketch. So here's our sketch here. Now, x squared equals 20y, you've got to think about that in terms of, first of all, what does it look like? Y equals x squared over 20, just by moving the 20 here. So it's just a normal concave up parabola. So that's the first thing, there's our parabola. Then we've got to put it in terms of this format, x squared equals 4ay. Now no matter what sort of parabolic locus we're looking at, x squared equals 4ay, x squared equals negative 4ay, y squared equals 4ax, or y squared equals negative 4 outside of ax. The parabolas, they've got to have that format. And that format provides us with two things. First of all, the sine of 4 tells us whether it's concave up or down. And then this tells us the distance between the vertex and the focal point. We can see straight away that the vertex of this thing is 0, 0. And you can test that by substituting x equals 0 and y equals 0. So that means that our focal point is up here at 5. And then we just can list this. The focal point is 5 units above the vertex because it's concave up, which is why it's above. The vertex and the directrix is below. Question 2. Here's the question. Find the equation of the locus. So it's equidistant from 2 points. Okay, so here are the 2 points that I've drawn, and I've just drawn a sketch before I start the work. The sketch shows the 2 points. It shows just a segment attaching, and we know that the midpoint here, well, we can evaluate the midpoint, but what a locus means is that the point P can move. Here's the point P here, here's the point P here. That the distance, whenever I've got a point P somewhere along here, this distance here is equal to this distance here. Or I could use it up here. This distance here is equal to this distance here. Notice I'm not really interested in what quadrant the x and y's fall in. Like I'm down here in the 4th quadrant, but I haven't put them both as negative, negative, because P moves. So P is positive, positive up here. It's negative, positive up here. You know, it moves all over the place, and that's what a locus is. So it's not about positives and negatives of x. X is a variable, and the answers will give us those depending on what points we're interested in. So looking at points that are equidistant, or a point which is equidistant from these, anchors, if you want to think of them like that, or fixed points, is we're just equating the distance. So the difference of the x's squared plus the difference of the y squared is the d. See, I've got here d, the distance PA. Here's the distance PB, which is this. And then it's just algebra, right? We square both sides, we expand both sides. X squared cancels with x squared, y squared, and we should expect that, right? Because what is this locus? It's a straight line. There's no x squareds and y squareds in a straight line. So I should be left with some x's and some y's, and I simplify. And that equation gives me the line in red. And if I choose any point on this, then it's going to be equally distant from B and from A. That's question 2. Question 3, sketch this thing, x squared equals 6 minus 2y. Okay, now, as I said right at the beginning, x squared equals 4ay. You have to put it in this format. So the first thing you might want to do is take 4 out. Now notice here, y is negative. So, and in the format, in our general format of a parabola, we have x minus a all squared equals 4ay minus b. Now, so the x and the y's always have to be positive. And so what that means is the 4 will change to positive or negative. So because I've had to bring the 2 forwards and make it a positive number, and you can figure out a by well, 4 times a half is -2. -2 times y is -2. Okay, so that's our check. And so then I can just sketch this thing. Now, don't forget, the vertex is found by the x minus, well, I should say x minus k all squared. So k, there's no k here, so it's a 0k. Y minus h is the y coordinate of the vertex. So -3 is +3. So when I put a 3 in here, 3 minus 3 is 0. So there's my 3, and there's my vertex. So now I can draw this thing. Okay, so that's my first step. Notice I scribbled this out here because it got a bit curvy. It shouldn't have been curvy. It's a parabola. So it would go straight down here. Okay, so if I can find my vertex, then I can have a look at my focal length. It's half. Because this is concave down, and I know that because of the -4, then half a unit below is the focus and half a unit above is the directrix. And if you're drawing this in a test, you just give it a bit more space. I also drew put the points of intersection of the x-axis just by letting y equals 0, and I get x squared equals 6, so x equals positive and negative √6, and that's how I got those two values there. Question 4. Now sketch this thing. Okay, well, the first thing you've got to notice is that this is not in the format that we need it to be in. We need it to be in, well, in this case, you can see there's an x to the power of 1 here, and there's going to be an x squared here. So this is a concave left or right parabola. It's going to have a y squared in it, and so what I need is y squared equals 4ax. Or generally, okay, y minus h all squared equals 4a x minus k. So that's the format, and so therefore I have to do something with this. And so what I'm going to do is expand it. Okay, and I get that line there. But if I need something like this, I need y minus k all squared. So that doesn't factorize like that, so I need to create a perfect square by adding 1 to here. And so I added 1 to make that 12 on the right hand side. Now what I've got is a perfect square on the left hand side, and by factorizing I got 12 outside of that, and 12 is 4, and a therefore is 3. So that's what you've got to recognize to do in this question. Having got that, we know then our vertex is -1 over here, 5 here. Now -1, 5, plot that straight away. We know that our focal length from here is 3. So now notice I'm just doing this a bit more carefully than the last sketch. 1, 2, there's 3 units there. 1, 2, 3 units out here. As soon as I put the focal point and the vertex and the directrix there, it's easy to sketch. So getting that information together will provide you with the information to sketch that. I haven't put the x-intercept here, but I could easily find that by letting y equals 0. And when y equals 0, I can solve that pretty straightforward. Okay, last question. Prove that the line, now this really should have said, determine if the line is a tangent, because it turns out not to be a tangent, and that's okay. But how do you do it? Well, again, it's about putting this equation into the general format of a circle, and that involves creating perfect squares. So when you're looking for perfect squares of a circle, you put the 5 over to the right-hand side. So there's that 5 there. I'm left with x squared minus 8x. How do I make that into a perfect square? Halve 8 and square it is 16. Halve 4 and square it is 4. So my 16 and my 4 get added to both sides. And this is what you'd expect anyway. A reasonably convenient number, 25, 16, a square number that gives us an even radius. Okay, so I know the circle has that and radius of that. And now what I'm looking for, and this isn't really a locus question, but find the distance, the perpendicular distance from that line to the center. And what we're looking for is that if this thing was equal, if the perpendicular distance was equal to 5, then that's the radius, so this line will be touching the curve, touching the circle. It's not, it's actually less than 5. And so, because the distance from the center is less than 5, this line actually cuts the circle. You're not asked to sketch this thing. Okay, so just in summary, it's gone longer than I had expected, but nonetheless, for all these things, x squared equals 4ay. You've got to get into that format. You've got to put diagrams on a paper to give yourself visual clues, and from there you should be able to work out all about locus.